What's up guys, Shawnthebro here, and today we're going to be going over basically part one of a little mini series that I like to consider fixing up our Capsule Collider and our collision on our characters. So right now we are using the basic Unreal character, and so we have our Capsule Collider, which is good. It handles things like physics and collision, and when you're playing your game you won't ever really notice anything off about it. You collide with your opponent, and that's about it, right? Nothing seems super weird. Nothing seems out of the ordinary. But if you were to go to your main menu, go to a mode where hitboxes and hurt boxes were enabled, you would see that we have our collision box, which is the yellow box in this case. And it only collides with the other character when one or more of the components collides with the Capsule Collider. So until the push box collides with the Capsule Collider, then we don't actually collide. So if I want to change the collision, it's not as simple as it should be, or as simple as a lot of the fighting games make it out to be, where you just see it, a character walks into another character, and you see that they maybe get pushed back, or because their hurt box is small, they can't collide with them, something like that. And so what we actually need to do is make it to where if your Capsule Collider is not bigger than your hurt boxes, which is pretty much never going to be because, our push box in this case, but because, we can resize it to whatever size we want. We can resize it during attacks and moves and crouching and all these different things. We don't want to have to resize the Capsule Collider for all those. Also, Capsule Colliders often aren't used in fighting games. It's usually these squares, these 2D representations of where the player could be hit, even if their body isn't really there. You'll see when you're playing fighting games, even AAA ones or bigger fighting games, you'll see that sometimes when the character gets hit, their head or their body part might be entirely out of the hurt box, and yet you could still technically register a hit by attacking them there. And it's just because the hurt boxes did not move with the animation. We need that full control when playing our game because we don't want the Capsule Collider to be in charge of everything. Otherwise, we won't have, again, that full control of what we're trying to do with our attacks and our animations. So long story short, in today's episode, what we're going to be doing is basically part one of 3 of fixing the Capsule Collider so that we can use our push box as our collision for our character as opposed to the collider. Now, we will still have the Capsule Collider enabled and still use its collision for walking and collision with the boundaries and things like that, most likely. But mainly the character should be changed to make sure the push boxes are affected by that. Alright, so anyway, today's episode is going to be all about not being able to land on the character's head anymore. While this isn't directly related to the Capsule Collider fix, it is going to be affected by the changes we make. And so I want to go ahead and get this sorted. Now, this is something that we've talked about for quite some time, and we've never actually implemented. So before, when the series started, you would be able to jump on your opponent's head, and you would actually bounce. And I can show you what that looks like by changing a few things. Okay, so if I go back into the game, I'll do it without the hurt boxes in this case, but it doesn't really matter.
Ready, fight.
When we're in our game, what it would do before is you would jump on your character's head and you would bounce off of them. While it might be a little bit funny, it's definitely not practical. And the way Unreal actually handles this sort of bouncing is that it chooses a random vector direction, believe it or not. I thought that was a very strange way to do it. And it just launches the character there. So you never know what you're going to get. Now, you could override this and make your own logic. But what we ended up doing, and we set this in the past, where we went into our capsule component, went to the collision. So on our base character BP, we went to the capsule component, went to the details panel under class defaults, and went to the collision section, and we set can character step up on yes. And so this is probably what you have, what you're going to see here is probably what you have currently. Let's load this up. And this is what it should look like now. So you would actually get stuck on the character's head, or you could actually just stand on it. Right now I do have some changes in place, which is why you're seeing him stuck in that animation. But you would be able to stand on each other's heads. And that's really not what you want either. So I'm going to hook this back up. And we're going to take one final look at it before we start the episode, just to show you what we've changed today. All right. So now if we try one more time, you see that I collide with the character, and it will pretty smoothly push me off to the side based on if I'm over the halfway point. So if I've passed over the character, then I will be able to land on the other side, like that. However, if I don't make it over the character, it will just push me back to the side that I was jumping from. It's pretty smooth. It'll be smoother when we get the other fixes for the Capsule Collider in, which is why I wanted to kind of address this now. Because if we address it later, it might not make too much sense of why we're doing it. But I think it is important that we cover it now. You see the difference. And then when we make the Capsule Collider change, we'll make one small change again to this logic. And then it should be even smoother than it is now. But in my honest opinion, it's not too bad. It's a little jittery, if anything. Like you can see that when I initially collide, it kind of snaps to the spot initially and then sends me down. And that can be adjusted, and I'll show you how in this episode. But again, this is part 1 of 3 of this fix for the Capsule Collider, and I just wanted to address this. So it should be a pretty simple episode today, but I want to make sure you are aware why I'm making this change. So if we go into the code, and before we truly get started, I believe this is episode 97 of the fighting game tutorial series. We have a ton more episodes to go. We have a ton planned, and but we've already come quite a long way. So if you do want to catch up on the series or check out everything we've done so far, I'll leave the playlist in the top right corner right here. You can see everything we've done and how we got to the point that we are at. Otherwise, I will just link this episode right here, which is all about basic movement and how we've restricted our jumps to have no air control and pretty simple stuff, but things that make a big difference in something like a fighting game. Otherwise, let's get started. So today we're mainly going to be focusing on the landed function in our character class. So if you go to your base character, mine's fighter template character, go to the .h, we're going to make a function. And I called it move character smoothly. And I've made it a blueprint implementable event. So what this is we are going to check and see if we've landed on an opponent, on another character. And if we have, we want to determine where they are in relation to where we are, so we know what direction we are going to be throwing our character or sliding them off of the character's heads. So I've made a U function, blueprint implementable event, and I've called it move character smoothly with 2 vectors, a start and an end, for where we're currently at and where we want to be. Simple enough. And then in our fighter template character.cpp, we can scroll down to our landed function. Now, last time you saw landed function was quite a long time ago. We have done a few things with it here and there, but mainly what we were doing was just making sure that, we were in these certain states, or we had this certain gravity amount. And it's good. Well, how it works with the gravity when we land is fine. We're definitely going to be updating it when we get into the actual air combat and things like that. But that can be left alone for now. We're going to pretty much ignore all of that and do everything related to this above it. So let me go over the entire landed function again, just so that you're aware of what I have and where we are at with this. And hopefully it'll make more sense. So here's landed. This is the super call, or basically the call to the parents landed. We don't actually use it. So in this case, you can get rid of it if you want. I left it commented out because when you have a character and you override the landed function, then, the parent would normally get called if you want to perform that logic. We don't need to, so I commented it out, but you don't need that in there. Now, this stuff, in fact, everything here, everything inside this if statement right about here is what we are adding today. Everything else is what we had. So basically, if we've landed and our character state is jumping, then we go into this if statement. And what we're going to do here is we're going to check and see if we've landed on our enemy's head. So right now we only have one enemy, and that's other player. However, you could have multiple characters, you know, tag battles, so we'll have to check for more in the future potentially. However, what we care about is making sure that other player is valid. So if other player, that basically just doesn't is valid check. If this is null, it will fail this if check. So if other player and hit.actor.get equals other player. So if other player is valid and the hit.actor.get landed has a parameter that comes in. It's passed by reference. That's what this ampersand means. So we have everything that this hit has in it. We can access it and check it out. So hit.actor.get returns the actor that triggered this landed function. So if this character landed on another character class, and that class is equal to other player, we know we've landed on the opposing player or our opponent. So that's what we're checking here. If the other player is valid, and that's what we've landed on. If that is the case, then we go into that if statement, and I just do if other player is facing right. Is facing right is updated based on if you are to the left or right of an opponent. And so it will be updated on tick outside of certain cases like if they were thrown or jumping. So this is probably a good enough method of checking if you should be launched to the left or right side of a character after jumping. However, if you want to be really precise, what you should do instead of checking is facing right, checking this boolean we have, is literally just check their Y locations to see which one is greater or which one is less than, and then moving the character to the appropriate side. For now, this is good enough for me, but we may need to adjust it in the future to make it a little bit more precise. However, this will be a little bit faster, so unless we need it, I'm going to leave it like that. Now, I've done 3 logs. It's not required that you do the logs, but it did help me a lot when I was actually writing this. So I have a log for a character is landed on top of another character, offset to the right. And alternatively, if the other player is not facing right, then the log says characters land on top of another character, offset to the left. Now, these other 2 logs are the same for both cases, but basically what it does is it grabs the landing character Y location and the landed on character Y location, just to print it out and just for me to see that it is working correctly. And so this is pretty simple, but if we go to our output log, we can verify this is working.
Ready?
Okay.
Fight.
So say I jump on my character. Character is landing on top of another character, offset to the left. The landing character was offset to the left, so that is correct. And you can see that the Y values indicate that the jumping character was to the left of the character that was on the ground. Thus, they should have been put to the left. So that is working. Alternatively, if I jump here, offset to the right, and you can see that the Y value was greater than the character on the ground, so it should have been offset to the right. So you can see that that is working as well. Okay. Again, it's not required you use the logs, just for debugging, so it's up to you if you put them in or not. But we have 2 possible methods we could use here. I'm going to use our move character smoothly method. You could actually just use set actor location, and it would work, but it'll snap. If you use this, it'll snap to the position. It won't even try to make it look nice. And I know it's a little snappy as it is now, but it's a lot better than the alternative where it literally teleports to the position. So here, if for whatever reason you would like to just directly teleport to the position, this commented outline right here is what I was using for that. However, I personally am going to delete them because I much prefer the actual lerp and being able to see where the character is falling. I think it looks much nicer, and it's much nicer on the camera because the character is not being teleported. So what we're doing here is we're going to actually make an F vector for the end, and we're going to use the get actor location for the start. So remember, move character smoothly is what we made in the header file. So it has 2 vectors, a start and an end. That's what we're going to be passing in both of these cases. Now, it's a little bit of a long list here, but I'll explain it, don't worry. So if the enemy player is facing right, that means that we need to be offset to the right. So the starting location for where we're going to do a lerp, which goes from one point to the next, from A to B at a given rate or interval or percentage or alpha. There's a ton of different ways you could explain it or use it, but basically it's going to go from point A to point B at a given ratio. And so the start point, no matter if we're going to the right or the left of the character on the ground, the character that we're landing on, we need to start at where our actor currently is. So we're just going to pass in get actor location. For the end, we're going to make a new vector. And I'm making up kind of arbitrary values here, which is partially where you can fix up some of the jitter that comes with this method. There'll be another point you can also make cleaner. I'll give you an example when we get there. But so the way I do this, again, I know this is very long, but you can see them both. So I type f vector, indicating I'm making a new f vector. I pass in get actor location.x. Vectors have 3 components, x, y, and z, so we do have to fill out all of them when we're doing this. Well, we're going to lerp to the same spot on the x because the x-axis is the one that gets locked, and we don't move. We don't go anywhere with the depth. We stay on the y and z planes in Unreal. X is the depth plane. So we're going to pass in get actor location.x. And then for the y, that's all of this right here. Whoops. Let me make this a little bit easier to see for you. If Visual Studio would stop fighting me. There we go. Right there. This is all for the y. So we're getting the current actor's location for the y. And then I'm doing this little bit of math in the parentheses here. So 120 minus f abs, or float absolute value, of get actor location.y minus other player get actor location.y. What this is really doing is the f absolute value, or fabs, is going to get the difference between these two to see how close they are together. Getting an absolute value just makes sure that it will be a positive value, not a negative, so we won't have to worry about sides in this case. Like if you're on the left or right, it's not going to change the equation for that. For this absolute value check, we don't care about that. We just want to know how close they are. So if they're super close together, say they are about 2 units apart, their y values are about 2 units apart, then we know that we need to do 120 minus this. Now, 120 is a completely arbitrary value. This should be given a variable or something of the sort. However, I'm intentionally leaving this like this for now to show you this is completely arbitrary. This is the value I've chosen that I like, both for the gameplay, for the speed of the gameplay. So if the characters are trying to walk in the direction that the landing character is being launched, they can't bounce off the head, they can't continuously land on them. 120 seemed like a good distance, that it was safe under all scenarios. You can feel free to use these values and then play around with them if you don't like them. Now I have get actor location.z minus 80 for the z component of this vector. Again, this is actually completely arbitrary, so feel free to change this as well. I chose 80 because I know my characters are at least 80 units tall. This is something I did by just looking at my Capsule Collider so that I knew where the collision would occur. And so if I actually look at it, I forget the exact height. The half height is 80, actually. So I actually made it exactly the height of the capsule half height. So I get the location of the actor, Z, and then I subtract 80 from it. You could do less than that, you could do more than that, but you don't want to put your character into the ground at any point. You want to make sure they're always above the ground. So this should really be like character height or Capsule Collider height. Or, again, when we end up fixing this in potentially the next or the episode after the next one, so 2 episodes from now, we will make sure that we are taller than the hurt box. That way we don't ever push our character into the ground. That's what we don't want. Okay. Alternatively, if we're not facing right, then it's the same thing, but we do have to change one thing about this equation. So you can copy the whole thing, but the get actor location.y, I multiply the result by -1, just to reverse the direction. We do absolute value in here because we just want to get the distance between the two players, and I do 120 because, again, that's how I get how far we want to move away from those players. However, this will always return a positive value since we're using absolute value. Positive value in this case is going to offset to the right. So if we multiply it by -1 at the end here, it will offset to the left. Okay? And there you go. I also make sure that I set the gravity scale back to default and change the gravity scale modifier back to default. Again, I don't entirely like this system. It's good for what it was, but we're going to get into much more complex stuff with air combat, and we're going to need to adjust this quite a bit. But for now, I'm leaving it alone. I'm following the rules we've already set in place as to not complicate this. Then, if this if check failed, I still do our logic we were doing before. We just had this if before, where we were checking to see if we were not landing on a hitbox actor because we didn't want to trigger the landing logic if we were falling into a hitbox, which is true. We still don't want to do that. But instead of just being an if, I put it in the else if because we only care about that if the character state is jumping. In fact, we honestly could care about it if they are being launched as well, but I'll ignore that again for now. We'll wait for more of the air combat stuff. And then this stuff is all things that have already been in here, so I won't cover all that. There is one thing that I didn't mention up here at the top above the if statement, where we check if the character state is jumping. I do something called get movement component stop movement immediately, and it's like this comment says: stop the character from moving with any momentum when landing. Ignore this if momentum is expected. And what I mean by this is when you land, we've restricted our air control, so we have a default speed that we are moving when we jump through the air. However, we may want to stop all the movement when we land on the ground. That way there's no confusion. Like, we don't want to land and then we're still moving, and that causes issues with anything else. Like, if we go into another move right away, we don't perhaps want to throw off forces by having the forces from our jump, and certain specific cases like this. So it's not required that you do this. For me, I think this is much, much cleaner because for me, for my game, whenever I land, I'm going to stop the movement. And then if they want to go into a different attack, then that attack, either with the root motion or with forces applied, will be completely separate from the momentum that the character has. So I personally just stop all movement immediately. It makes our lives a lot easier. We don't have to worry about where these other forces or other velocity on a character is coming from. As soon as we land, we're not moving anymore, and then we do our logic to offset them onto the ground. Okay. And then once we are done with that, you can build, compile, all that good stuff, and then go into your base character BP. And we're going to fill out our move character smoothly event. The way you get this is you just type in your base character BP or any character that you want to do this for. Event, move character smoothly. And it will look like this. We're going to make a timeline because the timeline is what allows us to kind of change the a lot of how we actually fall through the air. You don't have to use a timeline. You could use forces. You could use impulses. You could just use tick and allow gravity to do the work. But I'm using a timeline because we can choose the rate at which the character falls, like I said. And you can actually, you have a little bit of freedom with setting the actor location here. Remember, we were just doing it in the code. I said that would be too snappy. We have a little bit of freedom. We can lerp through here. I'll show you how to do that in a second. And we could actually set the actor location so that it moves pretty smoothly over time. Timelines are pretty good, so I'm also trying to use them for certain things like this where it can make things look nicer because they can be replicated too. They can be used online perfectly fine. as long as they're handled correctly. So could be something that we end up using more of in the future, but for now, this is just a little demo of what we can do with them. So you have your start and your end components of your move character smoothly. The start is the top line, the end is the bottom line in this case. What I'm going to do is create a new timeline. I believe it's add timeline. Yep, add timeline. You click this and you'll get a node. I already have one called Move Character Smoothly Timeline, but I'll go and create this one with you so you can see the process. If we double click this, it opens up the timeline editor. Now you don't have anything initially, it just looks like this and it's not very helpful. However, you can go to add a float track and it will add this little graph for you to be able to use. So if I went and I rename this to timeline test, it's going to actually rename the alpha value. Right here, you can see I named it alpha here, but here it's called timeline test because that's what I put here. This is what this value is keeping track of. It's actually keeping track of this alpha. So this float value here that gets returned, that's what that name is for. If you want to rename the actual timeline, instead of being timeline 0, you right click on it, rename, and call it timeline test. And that's how you get it like that. Now, you have a length, which is how long this takes to run, to complete. You can make it longer than where you put your nodes. It's just an example for, again, how long it can run for. However, you don't want to really extend this if you don't need to. Just taking up space and performing calculations that don't need to be run. So I usually like to make it about a second long. And then you can right-click anywhere on this graph and fill out the values. You can go from 0 to 1 as a good example for this. However, you can go higher or lower. Just understand that if you go higher than 1, it's going to be like you're doing 2 times this operation. And if you go under 0, then it's actually going to do the reverse operation. So a very, very simple graph would be right-click anywhere on here, add key to curve float 1, and then pick a time at 0.25 seconds. I want this to be halfway done. And then at, close to 1 second, I want this to be completely done. And then lastly, at 0 seconds, I want this to not have been started yet. And that's my graph. Now, here's my actual graph, so you can see my values. I've made the move character smoothly timeline take up only half a second total. I have my first value at 0, 0. My second value is 0.25 seconds. We're already halfway done. And then it evens out a bit and it takes until 0.075 seconds. We're completely one. So you could change the time to be 0.075 if you want to use exactly what I'm using, but you don't have to. Feel free to play around with this and check it out. I do have use last keyframe enabled, and what this will allow us to do is it'll make it a little bit smoother for us because it'll allow us to go from the last keyframe to the next one. Whenever we are, if we stop it and start again on the center, or not the center, at one of these keyframes. However, it's really not something we care about or need for now. You can see that it can be replicated, which is going to be useful for later, for any timelines that we have. I'm going to get rid of timeline test here because, quite frankly, I just don't need a second one. I believe you can find them in components under variables if you ever want to click on it and take a look at it. But we don't need to do that. So anyway, now that we have that timeline, you can drag move character smoothly into the play from start section. The play from start means that this will play from the beginning every single time that you trigger this event or go into that node. And this is good because we don't want to play, let the time finish, and then when we play the next time, it's going to start from the end, or it'll already be done. There are times you want to do that or set the time to start from. But in this case, we don't need to do anything like that. So I'm just going to play it from the start every single time. Now you have an update, a finished, a direction, and an alpha. We don't care about the direction in this case, but the alpha is how far along we are. It's actually, I believe it's this value right here that gets returned into the alpha. And so if it's 0.5, then we want to put 0.5 as the alpha for our lerp, because remember, lerp is from point A to point B at this rate. So point A to point B, halfway would be halfway between A and halfway between A and B. Literally just that. And we're doing this on update because we want to continuously set the actor location. As an example, if we only did this on finish as opposed to update and we ran this, you would actually see the results all at once, just like you would do if we just did the set actor location colon code.
Ready.
Say I jump on the character's head and I teleport to the location. Yes, it has the same effect, but it looks much uglier, and apparently there can also be bugs with it, probably if it doesn't grab landing correctly because it landed on the ground itself. So it's much nicer to do this on the update instead. And all I'm actually doing here is the set actor location node. Just like that. And I pass in the lerp to the new location. I don't check either of these boxes. And just in case there's any confusion, you use lerp vector here. And you pass in the start for A, the end for B, and the alpha for the alpha. All right, and that's what this event looks like. Now at this point, you're pretty much golden. You will be able to slide off your character pretty nicely, and you can change the two hard-coded values in the code, and you can also change that timeline as much as you'd like to make this nice and neat. However, this will work for all characters as long as they are above those heights. There is one thing that you want to make sure of. So when I go into my corner, I hit the barrier before I can flip the character. At this point, my character is all the way up against the back. So if I go into them, I will be slid out to the left, which is correct. That is how it should be. You don't want the character to ever be able to go into the barrier or outside of it, of course. You want to stay within the bounds. And since my one character is all the way up against it, then the jumping character's Y value can never be greater than that and can never force the character to flip. But it is something to check out for. Make sure that that is what's happening. If not, you have to make sure that your outside boundaries or your camera edges or your stage boundaries are A, they're straight so that, you know, at a higher point they don't change. B, that your character, its collider, whether you're using the Capsule Collider or in the future when we start using the push box in case we want to use that for the stage boundaries, that it is also not at any sort of rotation so that there's any sort of way you could land and make the character flip. However, there is something you could do. There's something you have to look out for. If the character is not, you see this? If the character is not up against the wall entirely, then it's still going to do the set actor location, and it is going to put them through the boundary, which will then put them outside the map. Now, if we want to make it so where we can jump on our opponent and be against the wall but not actually get stuck in the wall or get thrown through the wall, then there is a simple method that we already have access to based on something we made a few episodes ago when we were making our custom launch component. However, this will only work if we disable a few of the things we set up in the previous episode, which shouldn't be needed anyway. They were kind of workarounds, and you saw that I actually disabled this initially in this episode. It was not set up at all because I haven't been ignoring collision between these components. However, remember what I said earlier. We're going to be switching to make sure that we're using the push boxes and not just the capsule component. So at this point, we actually are fine to ignore the capsule component in cases like this anyway. So I've opted to do this. So I've re-enabled the ignore player-to-player collision. I've gone into the code. I've gone down to our jump function. And all these spots, if you're familiar with the custom launch character function that we set up, I had all these set to be true, this third parameter. This is if it should ignore the collision between two players. Custom launch character, this boolean right here, should ignore character collision. And it only sets it to true if this is true, of course. Otherwise, it'll be set to false on land. However, I'm opting not to set to true on any of these jumps. We don't really want that functionality. Again, that was more of just a workaround for the current state. And when we get the other hurt boxes in that handle more of the collision as well, we're definitely not going to need that sort of behavior with the Capsule Collider. So I'm just setting these to false by default instead of true. These are the only 3 places that I set it in the tutorial that you'll need to do it. If you want to find all your places, you can right-click on a function, hit Find All References, and somewhere this will pop up. You can click on them and it'll guide you to them. But I have it as false everywhere, other than that jump function. And you can feel free to just remove the last parameter entirely. It is simply an optional parameter that I've added. If you don't put anything, it's false by default. So either way will work. But basically, we do want to remove that because we actually want to use this function, and we're going to keep using it this time. It's going to be useful this time, not just a workaround. So what I've done is in the U function, in the .h file for the ignore player-to-player collision, I've added this blueprint callable tag. That way we can call it within the blueprint. We're going to disable collision just to perform the sweep when setting the actor location, and then we're going to re-enable it. This will allow us to move the character and use the sweep properly to block against the barrier so it won't go through the barrier, but the collision between the characters will be ignored so it can still do that. Remember, this only ignores the collision between the capsule components. I keep saying that because it won't stop any hits from landing and it won't stop anything with the hurt boxes from actually connecting or standing on each other, those sort of things. So it won't cause any issues down the line once we get all the hurt box fixes in. Until then, it might be a little bit strange. So feel free to look out for that. And if you find any issues, just remember, watch the next Capsule Collider Fixes episodes and see if that fixes your issue. Now, once you've done that, you can go back into the blueprint. And like I said, reconnect this if you haven't already, or if you already had it connected and never disconnected it, that's perfect. Quick reminder, what it really does is it sets the collision box. This is our push box. Can't see it because this is the base character, not the mutant, but this is the yellow box that determines the collision between the characters. It sets the correct collision response and then sets it for each character. It does have to set it for both characters because both characters have to be in agreement with how they're going to handle that type of collision. Again, this was all set up before, so you should have it if you've been following the series. If not, you can copy that now. And then this is what it looks like now. So I still have the same timeline, still the same LERP, but I've checked the sweep box. Now, the reason we have to do this is because if we don't ignore these collisions at the right time, and we check the sweep box, it is going to look like this. You're going to come into the game, you're going to jump on your opponent, and sure, you won't like fly into the barrier, but the sweep is actually saying, oh yeah, I've swept and I found something. It's finding the other character. Well, we already know we're colliding with the character, so it seems a little silly to have the sweep stop them. However, when we drag the update into the ignore player-to-player collision, and now since you've updated it to be blueprint callable, you should be able to just search for it and grab the call function section. Initially, we're going to ignore it because we want to ignore collision between the two capsule components to be able to do the sweep. Once the sweep fires and says, oh, I haven't found anything, then it'll set the actor location in the next spot. Then we can re-enable it. You could also re-enable it only when it's finished, if you'd like. It could be a little bit cleaner that way. Just make sure whatever you do, should ignore is false on the second one. We don't want to ignore it that whole time. We only want to ignore it so that we can perform the sweep and actually move our character to the correct spot.
Ready.
Now if I jump on my character, you can see that it does it correctly, where it still moves me to where we need to be. And then let's test out our corner strategies. So if we're directly in the corner, it will push me out the correct direction still. Nothing's broken with that. Now if I move slightly off the corner, I will get stuck on the character's head or around it, just like that. See, it's not quite the nicest, but this is actually a known issue. So this is going to require a fix on its own because we need to know corners in general. Not just for this fix, but for the actual Capsule Collider and Pushbox fix, we're going to make sure that if our characters ever get stuck inside of each other or try to collide with each other and they have to stop for whatever reason, such as getting stuck in a corner, we have to handle that a little bit separately, a little bit differently. And so that's going to be involved in one of the other parts with the Capsule Collider fix. If you want a quick fix now, just something you can do to set it up beforehand. If you get stuck in this state, so say you get stuck in this corner, then a lot of times there are a lot of ways to determine if a character seems to be stuck or is sitting in the air for too long. In which case, what you can do is actually push this character back, and that character will fall. And this is how it's done in something like Killer Instinct. If you actually ever play Killer Instinct, I know other fighting games do this, but I'm speaking with what I have the most knowledge from. If you ever play Killer Instinct and you watch the way jumps happen, what actually happens is the character on the ground moves out of the way when you jump on another character, not the character in the air. I've done the other route, but it doesn't really matter. In my opinion, it might look a little bit nicer if you do the character on the ground. I just opted to do this one because I thought it made more sense initially. However, feel free to do the exact opposite. This is a tutorial after all, and you can hopefully learn from it and do what you want with it. So yeah, now you have all your cases. You can't actually go into the barrier anymore, or through the barrier, but we do need to address this where we push the character that is being landed on out or away from the opponent. If you want a quick solution to that, what you can do is just flat out push the opponent regardless. Like we're setting the actor location here. What you could actually do is do a small launch character on the enemy if you'd like. You can do your custom if you want, but it's not actually necessary here. You can just use the regular launch character. Let's do other player. Should probably check if this is valid. However, we do check it before we call this function, so it will be fine. And we would need the direction that we're facing, which we could pass into the function. But you can go ahead and give it a -120. Let's try that. Don't know exactly how it's going to look because I'm just testing it out for the first time now. And now let's try one final time. So if we go into the corner, but not fully, then when we land on them, you can see it actually did push him, not nearly enough. I might be able to get the numbers completely correct. So if I come like right there, maybe, you can see that it pushed him enough out of the way so that the character could land. And that's really what you'd be doing. You can go ahead and do this at any point you want. You see I can push him at the entire time if I'd like. Every time I land on him, kind of push him out of the way. Right now, our jumping character is still being pushed out of the way, so if you want to go the ground route, just completely disable the logic we set up for pushing the jumping character and do the same logic on the landed character. You can even use a timeline if you want, just like we set up here. You can just use this, use the alpha lerp, and lerp from the distance they're at to the distance you want to put them at. And you would just not change any values on the z-axis. So just to be completely thorough and clear, if you go to landed, if you want to only change the character on the ground, don't do anything with the -80 here. Just use get actor location Z and only update the Y. You can flat out move the other character that is being landed on as opposed to this character. And after some minor adjustments, this is what I came up with that I think looks the best out of everything so far, but it could easily be modified more to get better results. So, on top of the move character smoothly, which I've now changed to have, let's update this, make sure everything is a float, just to make conversions a little bit easier on the computer. There we go. So now I've updated this from 120 to 80 and from 80 to 70. But I've also called other player move character smoothly and basically done the same operation on the character that is sitting on the ground. This makes it so they also get pushed out. So both characters are contributing to the push as opposed to just one. Again, you could do one or the other. It won't hurt anything. This is just what I'm doing at the moment because I think it looks the best. So I call other player move character smoothly. I use other player get actor location, other player for the X, other player for the Y. This is fine as is. And then other player for the Z, just like this. Just so you're aware, since we are using the other player to check if they're facing right or facing left, since they're the character getting landed on, if you do have that exact same logic, the -1 that gets applied here normally, that we spoke about earlier to reverse the direction of the force, will have to be changed since we are applying this force to the other player yet again. And then the final result is this. So we load up our game. And we do all the standard stuff. We'll go through it one more time. We can jump on the enemy head. Both characters get pushed out a little bit. Not as much as the jumper used to, but the character on the ground also gets pushed. So it's about the same. Maybe a little bit more. You could probably tighten that up. But let's try some of the corner techniques now. So now if we go to the corner, first of all, the slide on this looks a lot better in my opinion. It allows the character to completely slide off without any issue. There's actually like no jitter on this. It looks pretty much perfect. And then if we go slightly out, the character on the ground actually gets pushed out from the corner. And then the characters can continue to be on the ground as opposed to getting stuck. There will still be some weirdness like this. This is because of the Capsule Collider collision. If we were using the square push box or hurt boxes, this would not be so much of an issue. But the Capsule Collider is not flat. And there is actually something in Unreal we can check to fix that. However, we'll cover a lot of that next time. There's a lot more we have to do with the Capsule Collider, as I keep saying. And I don't want to make this more confusing than it has to be. For now, this is good. This should allow you to customize this as much as you'd like, either pushing out the enemy, pushing out the player, or pushing both to make it so where the jumping character always makes sure they can land on the ground again and not sit on the enemy's head. Anyway, guys, that's all I got for you. Thank you so much for watching. If you enjoyed, please subscribe. It does more for me and the channel than anything else you can do, and I really appreciate it. I'm going to give a huge shout out to my Patreon members and YouTube membership subscribers. Thank you guys so much for all the love and support. I really appreciate it, and I want to keep telling you how much I appreciate you. Thank you so much. If you had any issues with this tutorial or any of my tutorials, feel free to join the Discord community listed in the description of this video. I'll be happy to help you out with any of the issues you had and get you sorted and back on the right track. And anyway, guys, that's all I got. So thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.